Okay, YouTube here. I got a real fussy little client here. And we'll be building these, they're called sensor brackets. Made of aluminum. This guy doesn't even want file marks on his stuff. So, I'd say if you're just starting out, you gotta get your block square and know what your overall dimensions are. This one is 30 millimeters by 38 millimeters, and it's gonna have over here there's an M4 by 07 metric 4 millimeter thread. These are sensor brackets, so I would imagine that's where the fiber optic sensors go in. And for that, you're going to need an M4 tap for sure, and the dap drill for an M4, which is about, it's 07, and the depth and the pitch of it and depth of the metric thread is the same. So we're looking at 3.3. If it's 0.7 is the depth, is the pitch of the thread. The closest to that is number 30 in normal size drill. And that's all we need. We might need a little angle prop to do the 4 to 5 on the ends. And let's square the block up. Let's get started. This is Bridgeport, the ultimate Bridgeport. Arguably the best milling machine ever made. But because this client doesn't want marks either from file or hammers or any kind of dents on the part, try to get one size square. So my mill runs off 240 and I use a VFD. And there's a whole story about VFDs. It's always a good idea to make sure your cutters and everything is tight, your vise is tight, your piece is tight, the right speeds. In this case, aluminum. I'll tell you what, the RPM is equal to the cutting speed, which is like the surface speed of the metal, divided by the diameter of the cutter in case of the mill, or your workpiece in case of the lathe. So it's cutting speed times 4 divided by the diameter of, in this case, the cutter. And there's a whole bunch of guys that are smarter than you and I who came up with this thing. Cutting speed is just an approximation of your speed that you use. Your speed is also dependent on the rigidity of your machine and how well your setup is and how sharp your cutters are. There's a lot of little factors that make you adjust down, but this is a good starting point. It usually be the cutting speed times 12 divided by pi, divided by the diameter of the cutters or something like that. So they just come up with a round figure of 4. So in this case I'm using aluminum, so I use 200 for the cutting speed for aluminum. So if that stands for it's 800, and I'm using a half-inch cutter. So that means 1600. So 800, that would be a 1600 times a half. So right now, getting the cutter on, I'll just move down to about 50 degrees. now I'm just trying to get one couple square corners. With my dice properly squared, I do know that now this side is square to these two parallel sides. So I could sit this on there and do that side, and I could sit it up to cut the right length to that side. Now, because my client does not want file marks, so I have to be careful how I but the burrs have to be removed. I could use sandpaper, but not right now because I'm not to my final size yet. Just trying to get a good square face. So I could flip it up and use a single pointer. It's sitting down. It's great. And for newcomers, new machinists, the 2 flute cutters are always better for aluminum. If a 4 flute is what you got, then that's what you got to use. And I find a single point cutter is even a better finish on your aluminum. So this way, now I got 2 parallel sides and one side that's square to both parallel sides. So this side is square to both these sides. So I could turn this up to do the final sizing, that up to do the final sizing. But I'll switch over to my single pointer where it's a lot nicer finish. Move the drawing out of the way. Now I've seen instances where an index silicon carbide end mill, sometimes 5, 6 flutes, 6 teeth inserts actually, and people call it a fly cutter. I don't think there's anything wrong with that if you understand what it is. But I think the fly cutter is the single point tool. That's what I was taught by my mentors way back when. Make sure you're pretty tight there. No, I could actually group them so they both could come out at the same size. One thing, when you group them, you can't put them side by sides. You have to lock them onto each other. And with this dimension, I need 1.181, which is 30 millimeters. But I usually calculate the equivalent, because my machines are numbered in imperial numbers. And readouts can go between, but you know, school. And I'm like one of the transition generation between the metric and the imperial system. So I use them both when it's convenient to me. My machine has, I'm using collets. So sometimes the less stick out you have on your tool is the more rigid your setup will be. But you should always have enough to make adjustments. I'm just gonna get this sitting down here and give it a whack. There you go. Now, I do have automatic feed on this machine on my x-axis. So I'll stop and take a measurement. Since that's my first cut, you need to know where you are. Establish exactly where you are and how much you need to go to get to where you're supposed to be. So I'm at 1.350 and I need 1.180. Oops. So 350, 180. That sounds like I got at least 170 to go. So I'll take 150 and measure again. Or I'll take 100 and turn it over since I need to have that nice clean face on both sides. We'll get medium and start making big ugly cuts. I'll take 30s and 25s. I'll always give her another tap to make sure that violent cut didn't have her shifted, and sure it did. So always tap her back in place. There. But she's not even. There's still some movement there. And with aluminum, because they're not totally, never totally square on the faces, so you have a little bit of a difficulty on your first face look. So I'll clean this up. Let's bouncing back, so I'll have to give something with a more solid blow. See, that's sometimes you just need to give it a more solid blow. And there you go, she's sitting down right now. See, this that finish is beautiful. So anyways, if this was steel, then you would have to leave your grinding allowance, say tool steel, if it's not something you could finish on the mill. Because if it's going to be heat treated, you might need to grind it after to final size. That way you would leave your grinding allowance on there. But in aluminum, you go to finish size. So I'm just taking heavy burrs off because at the end product I can't leave any fire marks. But it's kind of difficult to machine things that make a burr without using a file. Aluminum is also pretty dirty too. It's easy to machine, but it's dirty. And I only trust my vernier calipers within 5/1000ths of an inch. I don't care if it's a digital or it's an old analog. A micrometer is always what you use to do your final sizing. So I always have my micrometer close by so I could check. Vernier gets you close, but when you're close, when you are very close to your final size, you should be using your micrometers. And right now, I'm at 1.295. So I'll just finish you then. So I'm at 1.295. I need to go to 1.180, 1.181, which is equivalent of 30 millimeters. That's pretty good. Let's see. So, I don't have my calculator close by right now. I should get one. So I was at 1.295, did I say? Roughly. So I was at 1.295, and I need to get to 1.181. So 1 from 5 is 4, 8 from 9 is 1, so I need to take 114 thousandths off. So I set my 0. On the dial here. And I'll take the 25 just like I was I could take 30, but I'm not going to get too greedy. Small piece. Not a little rush. So yeah, I think I took 100 off. So now it's always a good idea to double check, making sure you did take 100 before you try to eat your little final portion off. You don't want to find a mistake after you've made it. So it's always good because it's steel. I mean, you could, or it's aluminum, metal. You could weld it back. So now I'm seeing I'm at 1.202, and by vernier standards, I'm supposed to be at 1.181. So that sounds like I'm right, but because this shifted based on my violent cuts, I'm going to go 110. And if you think you can't replace the material and you don't want to do it twice, there's no harm in checking a million times. Always check twice, cut once. And this says I'm at 1.185. So I remove it and double check with the micrometer. Because I think I took I should be at 1.1890. There you go. I was at 1.185. So that's the importance of double checking. I need to go just 4 more thousandths of an inch to get to my 1.181. No harm in double checking. Clean her up. Make sure she's all clean. You don't want to be sitting on anything, because if you are, that could actually distort your dimensions. No, I just need to just tap her down so she sits. And there you go. Feeling pretty even there. Nice there. Okay, and that's one dimension down. Break those corners off carefully. And for beginners too, remember a file only cuts on the front stroke. So dragging your file backwards on your piece is only making your file dull. It only cuts on the front stroke. So when you pull it back on top of your piece, you're actually making your file dull. The file should be pushed forward. Same way you use a hacksaw. Although I've seen hacksaws that are cut on the reverse stroke. When you use that one, then you have to put the pressure on your reverse stroke and pull rather than push. Really don't like those, but they're out there. So now I have one dimension set. And now we're going to go again and do the other dimension. Well, this being a longer dimension, you would rather want to hold it deeper in the vise. So I'll change the parallels just so I could go further down in the vise. Which is better holding. Always is better holding that way. The more grip, the more rigid is your setup, the less problems you'll have. So we'll switch over to some shorter parallels. We'll get this one's out of the way. And always make sure your vise is clean all the time. Because as I said, one little chip could throw out your dimension over distance. Well, this thing is 2 inches, so I do have quite a bit to take off of it. And I need